Okay, good morning. This is Professor David J. De Los Reyes. It's March 7, 2023. The time's around 2 a.m. in the morning. Okay, my topic for this morning on my subject matter, advanced mathematics, is lesson number 16. Lesson number 16. My lesson number 16, okay, before I will proceed, I will check my camera. Oh, it's fine. Okay. We are now on lesson number 16, Advanced Mathematics. The topic for this morning will be a new topic, and this is one of the foundations of Advanced Mathematics. This is Laplace transform. If from the previous discussions, our solution is actually differential equation, okay? The solution for tonight will be the so-called solution by using Laplace transform. Meaning, if we are given a differential equation, to solve that differential equation, we could use Laplace transform. Uh, Laplace transform is same as the first solution, but it was a different technique. And I think this was invented by Mr. Simon Laplace. He was a French mathematician. That's why the term Laplace emanates from his family name. Laplace is actually a family name of the inventor or mathematician, okay, which formulated this Laplace transformation, okay. Laplace transform is actually a math technique for solving differential equation. Another technique for solving differential equation. And this is specifically applied to the so-called transient problems in circuit analysis. Okay, the main concentration of this Laplace transform is actually in the solution of the so-called circuit analysis. Like our previous discussion, that is an RLDC, RCDC, okay, RLCDC, RLAC, RCAC, and the RLCAC. So the concentration of this Laplace transform is in the solution of the so-called transient problems involving circuit analysis. Okay, let's try to bring out the so-called block diagram so we could, visualize how this Laplace transform works. The visualization is something like this. For simple math problems, it is something like this. If we are given a number, okay, and the problem is asking for a solution of that answer, the first solution is actually, you could take the logarithm of that, okay, what comes out with the logarithm of that number. This is synonymous to the Laplace transform. Before I will proceed with the main topic, Laplace transform. Okay? If we take the logarithm, what comes out will be the logarithm of n. After taking the logarithm of n by using table or by your calculator, you make some algebraic manipulations using plus or minus. So what will come out will be a new number. And to bring out the solution, you take the antilog. Okay, so what comes out will be the answer. Or for the first solution, okay, you just take what is required. It could be an addition, subtraction, or multiplication. What comes out is the answer. So actually, there are two options. The first option is actually by using the logarithm. Okay, you proceed with this, you get the antilog, what comes out is the answer. Or the other solution is that the direct solution. Direct solution is just actually, if the problem is asking for 2 times 2, you just operate 2 times 2 and what comes out will be the answer. Or the other solution is by using logarithm. And supposed to be the answer will be the same. Okay, on the Laplace transform, the block diagram will be something like this. Since we are solving for a differential equation, okay, differential equation. To solve this differential equation, we will use Laplace transform instead of the ordinary solution using differential equation. So by using the so-called Laplace transform, the first block diagram is the given differential equation. The second block diagram is actually capital letter F as a function of S. The third one is small letter f as a function of S. And the fourth block is actually the required answer. That is the function of t, or simply the solution. The concept is something like this. If we are given a differential equation, to solve for that differential equation using Laplace transform, so this is LT. Take the Laplace transform of the given differential equation. What will come out will be a function of S. It's an equation involving S, okay? We transform that differential equation from t to s. So what comes out will be capital letter F as a function of s. And by using pure algebraic manipulation, just algebra. So this is now the so-called importance of algebra. If you don't know how to algebraically manipulate, you're gone. So after computing for solving for capital letter F as a function of s, by using algebraic manipulation, what comes out will be small letter f as a function of s. Then to bring out the final solution, okay, like on the antilog, we will take the inverse Laplace transform. And here we take the Laplace originally. Okay, to take the final answer, we will take the inverse Laplace of this small f as a function of s. So what comes out now will be the solution. Okay. And the so-called taking of the inverse Laplace transform, I put it here. For the inverse Laplace transform, we will use tables of Laplace transform. There will be a table. There will be a table. This is, the first row will be as a function of t. The second one will be as a function of s. Okay? So, upon reaching this one, to take the inverse Laplace transform, just look at this. Okay? Look at this, and to take the inverse Laplace transform, you go back like here. Meaning we are taking the inverse Laplace transform. So what will be the contents of this will be the final answer. Okay? It is something like that. The sign for a Laplace transform is the big capital letter L, something like this. The meaning of this is sign for Laplace transform. The sign for Laplace transform is like this. Okay? Letter L, it emanates from the family name of the French mathematician who invented Laplace transform. Okay, let's try to bring out the general equation and how to take the Laplace transform of any given function of t dt. The Laplace, if I will try to read this one, the Laplace transform of function of t dt, this should be equal to the integral, okay, with the limit from 0 to infinity of that given function of t dt multiplied by this, e raised to minus st. If we try to use this equation here, what will come out will be a function of s. It is this. Okay? Then by using algebraic manipulation to bring out the small letter f as a function of s, okay, you just use algebraic manipulation. And to bring out the so-called final answer, you just take the inverse Laplace transform by using the table. We got supposed to be a table. Okay? Function of t, this is function of s. So, before we could proceed with the so-called Laplace transform of anything, we must have to derive all the relation of function of t as a function of s for Laplace transform. So that's actually the important thing on Laplace transform. Without knowing the table, you cannot bring out the solution. Okay? Because the solution is just after taking the Laplace transform, you just use algebraic manipulation, then go back to the table, try to look at it, and whatever you could look from the table, that will be your final solution. Okay, that's it, guys. That's the concept of Laplace transform. Laplace transform is another solution of a differential equation. Okay? It's another solution. That is converting that function of t to capital letter F as a function of s. Then by using algebraic manipulation, what will come out will be small letter f as a function of s. And to bring out the final answer, you take the inverse Laplace transform. Like on the first one, we take the antilog. Or these are synonymous, right? The concept is similar. Inverse Laplace is antilog, something like antilog on the first solution. We take the log, we take the antilog here. Originally, we take the Laplace transform. To bring out the final answer, we take the inverse Laplace transform. Okay, it is something like that. And the general formula or equation on how to take the inverse Laplace transform of any function of t dt. The Laplace transform of function of t dt should be equal to the integral from 0 to infinity of function of t, that given function of t, times e raised to minus st times differential of time. So I think it's a must that you should know how to integrate, and we passed by integral calculus already. Okay, that's it, guys. So for those people or person or student who are taking up advanced mathematics, this is one of the important things under advanced mathematics, that is Laplace transform. Okay? So if you like this video here, please click like. And for those who would like to subscribe to my channel is at youtube.com/@prof.david.J. And if you want to share it, please click share. Good morning from Los Angeles.